Because in the solution to the problem up here, we used the idea that since 5 was fixed, and as x headed towards infinity in the denominator, the overall ratio was heading towards 0. I want to mention a few of these forms along with the previous forms we had and put them all together here. It's not necessarily a list of rules to memorize per se, like blind memorization. It's just thoughtfulness about ratios and what denominators and numerators are doing. So again, we had the limit of a ratio as x approaches a. All right. Now a could be infinity at this point. I'm just going to write a just to have some symbol there. It could, it could have been x approaches infinity or something. It doesn't matter per se. So if that will turn out to be, what cases do we have? We have 0 over 0. So that is a legitimate indeterminate form. I know I mentioned this already, but these forms are extremely important. Indeterminate form. If it had been instead 0 over finite non-zero, then that would automatically be the same as 0 itself. It's not indeterminate. It's totally determined. Right? And if it had been finite non-zero over 0, that's what we saw f and g were approaching. If f was approaching a finite non-zero value and g was approaching a 0 value, we would know it was some sort of infinity. I'm just going to use the symbol without plus or minus on it. Some sort of infinity. Okay? And that would be a d and e. Okay? We have something which could be a limit, finite value. We have certainly a finite value, 0. It's hard to get more finite than that in a sense. And then you would have an infinite value here, a d and e. Right? So now, if you switch the roles, you could have infinity over infinity, as we mentioned at the beginning of this, and that's a legitimate indeterminate form, and may turn out to be a finite value after all, as we saw. Ours was 1/2 just a second ago. So if we start replacing the zeros with infinities, what if the top? What if f is heading towards infinity and the bottom is heading towards a finite value? What if that's the case? Well, then the top is growing very large and the bottom is not, right? So therefore, this should automatically be infinity. Numerator is getting large, bottom's not. Pretty straightforward. If we say finite value here, over some sort of infinity. So now f is heading towards finite value and g is heading towards something infinite. What do we expect? We expect it to be 0. Top is heading towards something reasonable. The bottom is heading towards something gargantuan, beyond gargantuan, without bound, larger and larger and larger forever, just shrinking this ratio down and down until it heads towards a magnitude of 0. Okay? So you see the switch of roles here, right? 0 over finite, 0. Infinity over finite, infinity. Finite over 0, infinity. Finite over infinity, 0. Right? So when I wrote finite value here, it does include 0 itself. 0 over infinite case is 0, right? I mean, the top's already heading towards 0 anyway, and the bottom's getting very large, which is making the overall ratio even smaller towards 0 faster. So to here, as the top heads towards infinity, it's getting very large, and if this finite value is heading towards 0, it turns out, then that's making the ratio bigger and bigger from both directions, in a sense. Now over here, If you had 0 or infinity, it also works. It's supposed to be 0. Top's heading towards something magnitudinally small. The bottom's getting larger and larger and larger and larger without bound. That's shrinking this value down to 0 even faster. They work in tandem to make it go to 0 even faster. So to this one, if the top is heading towards a finite value, which is non-zero, or something infinite even, it's heading towards infinity, the top's getting large anyway, the bottom shrinking towards magnitude 0 is simply increasing the size of the overall ratio. So now again, they're working in tandem to make the ratio extremely large. So again, these are not rules to memorize coldly. Just you're going to run across so many different situations. The main idea is to think about what the numerator and denominator are contributing to the overall size of the ratio and where that's going to make the ratio head altogether. And in these cases up here, like I said before, you don't know where it's heading. Top's making it smaller, bottom's making it bigger. So what's going to be? Same idea here. In reverse, top's making it bigger, bottom's making it smaller. So what's it going to be? It turns out it could be anything. And in most of the cases it'll turn out to be something finite because these are trumped up textbook questions.